Which one?
See, the advantage of coming up with the chalkboard is, remember on the first day of class we talked about chemistry study strategies and how deliberate practice helps you improve and get better. So this is an example of this. You're up here in front of the class. You don't want to embarrass yourself. Practice is hard to figure out how to answer the question.
Dave's giving me all the wrong answers.
Get it right, Anthea. It's on tape.
Okay, so Rolando's amide is the correct structure. Okay, so he got this structure by doing this. So we have, so here's the alcohol, and here's the, sorry, here's the acid function group.
What?
No, the hydrogen group right
There is the
yeah.
amine functional group. Okay, so we're going to ignore this amine functional group and the other acid functional group. So this bond breaks on the acid. This bond breaks in the amine. The OH and the H combine together to form water. And then Rolando showed that this carbon bonds to that nitrogen, and this is the new bond that forms.
Can you circle the amine group?
Circle the
Amine group?
see it.
The amine group?
Oh, yeah, so the amine group is this one. We have one amine group here, and the second amine group is right here. Those are the two amine groups. The amide group is this one here. Okay, so this is the amide. Okay, so that's the amide. We have two amines. That's actually the amine I should have put this way.
The reason why you don't take the OH off the right side?
Yes, that's the second possible answer. So what you can do is you can take this acid and that amine to form a second product. Yes, so either way. Okay, so again, this reaction is very similar to that alcohol plus acid to produce the ester reaction. And then this is the reaction again, which is with amino acid. So this amino acid, this is glycine. So this is the simplest amino acid. And then this amino acid here, this is alanine. And the structure that Rolando drew is the structure of a dipeptide, a 2 amino acid peptide. And then, to do the reverse, this bond breaks, so this peptide can undergo hydrolysis to make the amino acids again. So this would you need a certain you need an enzyme to break this bond in the body.
You said there are 2 possible answers?
Yeah, so the other possible answer is, let's actually draw this way. So if you have okay, so I'm putting this one here. This is the alanine. And this is the glycine. So in this case here,
I was going to say, which one is more likely to happen in the lab or in nature?
they're both equally likely.
For the amine group, does the nitrogen not have to be connected to 2 carbons, or?
Oh, that's that. See, if the nitrogen connect 2 carbons, that's going to be called a secondary amine. Okay, so in this case here, we didn't talk about that. So this is an example of a primary amine because there's 1 carbon bond to this nitrogen. So just like with alcohol, we can classify amines as primary, secondary, tertiary. That won't mean anything. Yes, so in this case here, this bond breaks, and that bond breaks. The H and the OH form water.
Is that the way around?
Okay, so note here, this is the acid group from glycine reacts with the amine group and alanine. In this case here, it's the other way around. The acid and the alanine reacts with the amine and glycine. So we have 2 different bonds. Okay, then I want to mention one more thing about the acid plus alcohol reaction. Okay, so in our body, what happens is if you take 3 fatty acids, which is the simplest type of fat, this reacts with a 3-carbon compound which has 3 alcohol functions. This is glycerol, and that forms a triester, which is also called a triglyceride, plus 3 waters. Okay, so this is how fatty acids are converted to triglycerides. And then, in the reverse, these triglycerides are converted back to fatty acids. George.
You use
Okay, so let's move on to the next slide. Okay, this is about plastics. So plastics are polymers. They're made from alkenes. Now, when they're made from alkenes, these are actually called addition polymers. Now, let's go back a couple of slides because we said that with alkenes can undergo addition reactions. Okay, so one way to make plastics are from alkenes, and these alkenes can undergo addition reactions to make these long chains. So these are the recycling codes with 7 of them. So I think we so anyway, very common ones are HDP, high density polyethylene, or low density polyethylene. It comes from the ethylene alkene. Here's a few other ones. Here's PVC, polyvinyl chloride, that comes from vinyl chloride. PET is polyethylene terephthalate. PP is polypropylene, PS is polystyrene. If you're interested in how to make plastics, you can take a look at this website here. Note that these plastics have different properties. So high density polyethylene is used in milk and these washing up liquid bottles. Low density polyethylene is used in carrier bags and bin liners. Polystyrene, these are these foam trays or these styrofoam cups that we use. PET, these are used in these fizzy drink bottles, like soda bottles. PVC, again, food trays, clean film. Okay, so polyethylene is a common plastic. The monomeric unit of polyethylene. So what do you think polyethylene comes from? Methane, or ethane, or ethylene? Yes, it does. You know exactly where this comes from. Then how is polyethylene made? So if you have many ethylene molecules and it's treated with the catalyst, what happens is you get this long chain. So what's happening is the carbon-carbon double bond is breaking and is forming a single bond between two